Okay, maximum and minimum of functions of several variable. There are some explanations, but no need. You will check your textbook for this explanation. Sorry. So I'll just give you the working rule. The working rule to calculating maximum and minimum. In 106 they taught us maximum and minimum. I guess you have stationary points, critical points. Like those are the turning. So it's like a graph. The way my teacher explained it to me then, it's like a graph. So there are local points. How do I put it? Like for first derivative, you check the left, check the right, maybe minus by half, add by half. If it suits your condition, you get maximum points. Then if you're using the second derivative test, how do you know now whether you equate to zero, something, then I can't really remember again, but it's just something simple. So that's what we're doing here now, but by partial differential method. So the working principle, given z is equal to f of x comma y. The first step, find partial z comma partial y. So find partial z partial x and partial z partial y. And then as extreme or stationary or turning or critical points, you could use either of these names to tell you. Okay, they could say find the stationary point or find the extreme point or the turning or the critical points. So at these points, partial z over partial x is equal to 0, partial z over partial y is equal to 0. Now they said solve the resulting simultaneous equation in x and y. Let x naught comma y naught be the pair of values for x and y. The fourth one, this is my lecturer's working principle. It's the same thing, just although in the textbook they didn't really specify that these are these s and these t. He just did it this way so that we don't get to be writing everything square, this square minus, so that we could just write a root t. Like here now, we're supposed to write this square times this square minus this square greater than 0, but to make it easier I'll just call it a root t and s. So now calculate a root, which is partial square z over partial x square, s, which is partial square z over partial x partial y, and t, which is partial square z over partial y square for each pair. Now if r root c minus x square is greater than 0 and r root is less than 0 at x naught y naught, so at that point, if it's greater than 0, if r root c minus x square is greater than 0 and r is less than 0 as x naught y naught, then f of x naught y naught is the maximum point. If r root c minus x square is greater than 0 and r is greater than 0 at x naught y naught, then f of x naught y naught is a minimum point. If r root c minus x square is equal to 0 as x naught y naught, the case is doubtful and needs further investigation. If r root c minus x square is less than 0 as x naught y naught, then f of x naught y naught is a saddle point. So let's take an example. They say find and classify the stationary point of the function f of x comma y is equal to x to the power 3 plus 3xy square minus 15x square minus 15y square plus 72x. This is 72x. Solution: we bring down our f of x comma y. We find our partial f. Recall I had to put I so that we know the steps. So I find partial f partial x. Partial f partial x is this 3x square, this 3y square, this minus 30x, and this 72, this 0. So this for partial y, this 6xy, this minus 30y, 0 0 0. So that's our stationary points. We said this is equal to 0, this is equal to 0. So our stationary points, we have that this is equal to 0 and this is equal to 0. Now the easiest one to get values from is equation 4. I call this equation 4. So from equation 4, if you factorize 6 and y at the common this in here, so you have 6y brackets x minus 5 equal to 0. and implies that 6y is equal to 0 and x minus 5 is equal to 0. So for 6y equals to 0, y is equal to 0 over 6, which is 0. For x minus 5 equals to 0, x is equals to 5. Now the next step of the equation of the existing solution, which I don't know why it's so, because if you have two values, you also use the two values, but when I use x, you will get the saddle points. When x equals to 5, you substitute it here, you get the corresponding values of y. Y is square, so you get two values, you get plus and minus 1, I suppose. Then let's just go. But for this solution, we use only the y. So now I've said when y is equal to 0, we substitute y equal to 0 in equation 3, and you have 3x squared plus 3 bracket 0 square minus 30x plus 72 equals to 0. This is 0. You have this equation, divide through by 3, you have x squared minus 10x plus 24 equals to 0. You can use pairs of factor. What will you multiply? That will give you 24, and when you add it, you have minus 10. Minus 6 times minus 4 will give you 24. Minus 6 minus 4 will give you minus 10. So you just open this in your pairs of factors. So you have x squared minus 6x minus 4x plus 24. You do your grouping in case you didn't really understand it when others were doing it. So you do your grouping. You collect the common this thing. For this one, the common factor here is x. X into x squared will give you x. X into 6x will give you 6. This one, the common factor here is minus 4 brackets x minus 6. So we've ensured that the brackets are the same. So we collect this and collect one of these equals to 0. So it implies that x minus 4 is equal to 0 and x minus 6 is equal to 0. So for x minus 4 equals to 0, x is equal to 4. For x minus 6 equals to 0, x is equal to 6. Now recall. We said when y is equal to 0. So when y is equal to 0, we have x equals to 4 and x equals to 6. So the pairs of values now, like the stationary points, are 4, 0. So these turning points, like you have a graph, you have maybe something like this. The maximum points where there's the turning occurs, I think it's kind of like the apex points where the turning occurs, somewhere here too, and somewhere here. But now, okay, let's say since our points are 2, we have this and this. So it could be that one of these, okay, well, it doesn't even suit, sorry, it doesn't even suit the points, but you just get what I'm saying. So it could be that one of these points is a maximum and another point is a minimum. So it's the points that will determine. You could be asked to sketch the graph. You could be asked to sketch the graph, so you have to learn it. So when we check these ones now, which one is maximum and which one is minimum, it's going to determine the graph. So you just do your graph, put the coordinates. So let's say 4, 0. 4 is your x-axis, so it could be that at this point 4. So at 4 you could be having, let's say 4 is the maximum point, so you could be having your graph like this. And let's say 6 now is the minimum point. Ooh, how do we even do that? Oh no, let's say what I just, okay, it could go this way. I don't know what I'm doing, but then let's just but you get what I'm saying, that on 6 you should be having this kind of curve on 6. Y on 4 you should be having something like this on 4. That's what I'm saying. So you could be asked to sketch the graph. Who knows? You have to read about it. Alright, so we've gotten our stationary points 4, 0 and 6, 0. Now we solve for R, S and T. R is partial square f over partial x square. Partial square f over partial x square is going to be 6x minus 30. Yeah, yes, 6x minus 30. That's what I have here. 6x minus 30. For partial square f over partial x partial y, for partial y differentiate with respect to x, you have just partial x partial y differentiate with respect to x. You're supposed to have just 6y, yes, 6y differentiated with respect to x, you have 6y. This is 0, that's why you have 6y. Then partial square f over partial y square differentiated with respect to y, you have 6x minus 30. 6x minus 30, that's what you have here. So for points, we start with the smaller points. For point 4, 0, you now do at arrow as 4, 0. Record these are arrows. So at 4, 0, we have 6 bracket 4 minus 30 equals to minus 6. At 4, 0 is equal to 6 pi. So that's 6 bracket 0 equal to 0. And then for t at 4, 0, because t is the square f over the y square. At 4, 0 is you substitute your x here, so you have 6 bracket 4 minus 30, which is equal to minus 6. Then we now solve. Recall we said we should solve for our root c minus s square. After solving for our root c minus s square, we got 36 is greater than 0, and our root is minus 6, which is less than 0. Let's look at the conditions for our root c minus s square greater than 0 and our root less than 0 at 4, 0. It implies that 4, 0 is the maximum point. So we just satisfied that condition. Now our r is minus 6 less than 0. Our root c minus s square gave us 36, which is greater than 0. So 4, 0 is the maximum point. Now for point 6, 0, we solve for r at 6, 0. R is 6. We solve for s at 6, 0. S is 0. We solve for t at 6, 0. We have this to be 6. Now therefore our root c minus s square is 6 times 6 minus 0. That is also 36, greater than 0. And our r is 6, which is greater than 0. For our root c minus s square greater than 0, our root c minus s square greater than 0 and r greater than 0 at 6, 0, then 6, 0 is a minimum point. So this condition is also satisfied. Therefore 6, 0 is a minimum point. Alright, let's take a look at another example before we end things for this topic. Example: show that the stationary points of the function z is equal to x raised to power 3 y squared bracket 12 minus x minus y is 6, 4. So they said show that the stationary points for this function is 6, 4. Then determine the nature of the stationary points. Determine this if it's maximum or minimum, and find the functional value of z at this point. So they said we should show, having solved this using our working principle, we should show that the stationary point is this. Determine the nature of it, so check if it's maximum or minimum, and then find the functional value of z. That's just put this 6, 4 here to get the functional value. So let's go through the working principle. Alright, so we have z is equal to this, x is power 3 times y raised to power 2 bracket 12 minus x minus y. Z is equal to, open it up, you have 12 times this times x, this times y. Partial z over partial x. Now I'm no longer putting y, so this is like just how you should solve it normally. Partial z over partial x, differentiate this, you have 36x squared y squared, you have 4x power 3, y raised to power 2, you have 3x squared y raised to power 3, partial z, partial y, this 24x power 3y, this 2x power 4y, this 3x power 3, y raised to power 2. That's it. At stationary points, this is equal to 0, this is equal to 0. Equation 1, equation 2. From 1, we take out the common one, so x square, and x square. Although this is x is what we can find x square, so we bring out x square. We also have y square, and y raised to power 3, so we can bring out y square, and we have this. From 2, the highest here, we can take out x to the power 3, we can also take out y, so we bring out x to the power 3 and y, and we have this equal to 0. So you know that this is equal to 0, this is equal to 0, this is equal to 0, this is equal to 0. If we bring out these two, we can't really solve anything with it. They are both equal to 0. When y is equal to 0, x is equal to 0. The same thing for this one. So we work with these ones. Yeah, math is funny. When I used to study solution, like, what the hell? But we work with these ones. Bring out these two equations. Now, I was having issues here at first. I was having major issues because normally, the first thing you just go like, okay, let's use the elimination method. We want to eliminate this one, so we minus, right? So that this becomes plus, this goes out. When you minus, this becomes plus 2. So minus 4 plus 2 give you minus 2. When you minus, you have 12 here. So you're having minus 2x is equal to, okay, you're having 12. What the hell did I do? Are you kidding me? You're having 12 minus 2x is equal to 0. You can just take I was tired yesterday and I had to do this long walk. Jesus, I said using substitution method because you're like, okay, this stuff isn't working. Like it's not dividing. I was having 12 and minus 2x. That's the thing when you're trying to think some. Don't worry. See, when you're solving math, just try to write down some things. It will help you. I was doing this stuff in my head over and over and over, and just like it didn't work. But now you're having 12, you're having minus 2x is equal to 0. When you take 12 to the other side, you're having minus 2x is equal to minus 12. Divide both sides by minus 2, x is equal to 6. So you could use elimination method, but then I feel like elimination method did not work, so I had to use substitution method. And then, as I said, from 6 you have make x subject to formula. You move this over, you have 3y minus, move this one over, you have minus 24 all over 2 minus sign because of this. When you open the minus sign, you have 24 minus 3y over 2. Substituting value of x in 5 gives this. Don't really want to talk about it since you already know elimination method will work. Like it will just take 1 or 2 lines. Shit. I feel pain. So we have this 6, we have x. Okay, we go y equals to 4. Okay, see, there's a need to talk about. So we go y equals to 4. We substitute our value of y back in 7. Where's 7? This is 7. We put y as 4 in 7 and we got x to be 6. So we've proven that 6,4 is the stationary point. So for the other one, just use the elimination method maybe when you're solving it, or you could see substitution method. Either one is okay. So we get our r is this, s is this. Sorry, I'm going to be a little bit quick because my phone, the flash, turns off by 20 minutes of the video and we're already at 18 minutes. So we have r this, we have s this, and t to be this. At 6,4, we do our r at 6,4. r at 6,4 will give you minus 2,304. S at 6,4. Sorry, so we have s to be s at 6,4, t at 6,4. So s at 6,4 give you minus 1728. T at 6,4. T at 6,4 will give you minus 2592. So we do r root c minus s square. R root c minus s square will give you this plenty number, and it's greater than 0, obviously. And our r is minus 2304. So r root c minus s square is greater than 0. R is less than 0. It implies that the point is the maximum point. So we've answered the second question. The first one, we've shown that that's the stationary point 6,4. And then we've you see the touch just went up, I have lights here. We've shown that that stuff is the stationary point is 6,4, and then we've shown that it is, we determine the nature now is the maximum point, so it means that 6,4 is a maximum curve just at that point there. That's the apex of that curve. Now the functional value of z, x, y at this point is, I told you just put it z at 6,4. Where's our z? These are z, so you just put 6,4, z 6,4. When you put z 6,4, this is what you have. Your final value is 6912. Alright, so just go through it. Sorry, I had to rush it a bit. So be sure to figure out how I got R, figure out how I got S, and how I got T, ensure it's correct, and that's it. If you have a question, be sure to drop it on the platform.